Example 1, we're supposed to factor xya minus 4a plus xyb minus 4b. A while back we first learned about factoring. Lesson 69, I believe, was factoring trinomials. I think binomials were shortly thereafter, and we have that factoring table. This is how you factor. The first step on the factoring table was step 1, factor GCF. That's still the first priority. So anytime it says to factor, first thing you want to look for is whether or not there's a letter or number that evenly divides all of the objects in the polynomial we're going to factor. So, looking at each term individually, xya, 4a, xyb, 4b, we're looking for a single letter or number that evenly divides all four of those things. That's always our first priority on factoring. Can anybody see any? No, there isn't, right? So, no common factor. It's still a check. You have to do it. You need to do that every time. Always do that first. All right? After we've gone through the task of factoring the GCF, if it has one, the next thing, the chart was broken into binomial. We look for difference of squares. A trinomial, we have our factoring chart. For a polynomial of 4 terms, we're going to do factor by grouping. And factor by grouping is a technique that employs the whole idea of the greatest common factor. Okay? We've already established this doesn't have a greatest common factor amongst all the terms. What we're going to do is we're going to group things together, and within the groups we're going to find a common factor. So, what I like to do always is group the first two and group the last two. Sometimes that works. When it works, we're in good shape and all is well. When it doesn't work, we're going to have to rearrange a little bit. When I do group it, I don't want to change the overall structure of the problem. So here's what I mean. I'm going to put parentheses around the first two terms. That makes xya minus 4a. I'm going to put a parentheses around the second group, and notice there's a plus sign right here, so I'll put a plus sign. And the second group is xyb minus 4b. I want that green, red, and blue object that I just created to be the exact same expression that I have up above. And we verify that. Positive in front of xya minus 4a makes positive xya and minus 4a. A positive in front of xyb minus 4b makes positive xyb minus 4b. This expression is equivalent to that top expression. That is a requirement when you factor by grouping. When we get to example 2, you'll see that doesn't always happen. We might have to modify a little bit. What I'm looking for within each group then is a common factor within the group. So I don't care about the whole problem at once. I'm just looking at these first two objects. Looking at xya and 4a, do they have a common factor? What is it? Something that's a. A is in both of them, right? So the blue group has a common factor of a. So if I extract the greatest common factor of a out of that group, dividing a out of each object, xya divided by a is xy, minus 4a divided by a is minus 4. And again, that's mathematically equivalent to what we have above. If I do a times this, it's a times xy makes axy, a times minus 4 makes minus 4a. So I haven't changed any mathematical structure to this. Plus is still plus. Looking at the second group, is there a common factor?
B.
B. B is here, B is here. They both have B. So I'm going to take a B out. And if I take B out of xyb, I've got xy. Take a B out of 4b, I've got minus 4. Notice again, still mathematically equivalent. Positive b times xy makes positive xyb. Positive b times negative 4 makes negative 4b. Okay, so I grouped. I took out common factors from each group. And what should happen when a good factor by grouping problem is happening is this object and this object should be exactly the same. Okay. Now, back in lesson like 73 or so, we learned about binomial common factors, right? We have x plus y times x squared plus x plus y times 2x plus x plus y times 1. We can take an x plus y out because it's attached to everything, right? I got xy minus 4 times a. I've got xy minus 4 times b. Term 1 blue, term 2 green. Two terms have a common factor binomial of xy minus 4. If I take xy minus 4 out of this entire expression now, what's left from the first object, I took this out, what's left is a. And I took this out, what's left is b. And there's a plus sign between them, so I put a plus sign between them. Factored form is and always will be factor 1 multiplied by factor 2. All right? The plus sign goes there. I've seen people put pluses in between these parentheses. That's wrong. All right? So common binomial factor comes out. Whatever the greatest common factors were go in the second parentheses. Those two parentheses get multiplied together, and that's the factored form of our polynomial. And that is what factor by grouping is. That's how it works. Every single time you do factor by grouping, that's how it's going to work for you guys. There are some more complicated factor by grouping problems we might hit in geotrig that involve some other patterns that you're going to recognize hopefully by the time you get in geotrig. But right now, that's what a factor by grouping problem for Algebra I looks like. Group, group, common factors out, common binomial factor in one, greatest common factors in the other.